So let me show it thing the hardware version with the help of a lab, so that will be much easier to understand. Okay, so the lab console is visible to all, right? Thank you, Arvind.
Can you please remind us the name of the lab?
Sorry? Okay, so the hardware version is like when I select a VM, all right, you will see this VM here. It's 16 right now. Okay. Now, what is the impact of this VM version or hardware version? So if I right click VM and go to edit settings, now in the hardware you will see certain options that are not present in the lower hardware version. For instance, if I click on add new device, you will see here this NVMe controller, right? This NVMe controller comes only after hardware version 13. If you select hardware version 11, this NVMe controller will not be there. It's a new hardware feature for the VM. Okay. Similarly, if I go to network controller, I can, okay, let me add a new network controller. You see here this PVRDMA. This PVRDMA adapter is present only after hardware version 13. If you select hardware version 11, 9, 8, this PVRDMA will not be present there. So hardware version basically define what all hardware features will be available on the virtual machine. Does this clear your question?
Yes, Vinay. So basically, yeah. So this got clear, but it's not necessary every time they release a new hardware, right? If there is any change, we'll get the new version. Otherwise,
Right,
it will be the latest.
right, absolutely yes. Generally, whenever a new ESXi version is released, they tweak some features into a virtual machine. They introduce something new, so they will release a new hardware version. Generally, it always follow the pattern of releasing with the ESXi. You will never see a hardware version being released apart from the ESXi itself.
Okay. So whoever purchasing that, they need to take the new hardware also. For example, this is open source, right? It's available for anyone. So when we try to download and install this, do we need any hardware also?
Uh, Install what? ESXi?
Yeah.
Yeah, absolutely. You will need a hardware because ESXi will at the end run on a hardware itself.
Okay, so we need to configure that using the whatever yesterday we discussed, right? Multiple way to
Right,
configure the
right.
ESXi. So one of them. Okay,
Yes.
thank you.
Okay, no problem. Okay, so now let me give you a brief about these two new features. So RAM is fine, okay. Previously it was 4 TB RAM, now we can attach 6 TB RAM on a single virtual machine. But what is this NVMe and PVRDMA? Does anybody have any idea about these two features? No
No.
problem. So let's take the NVMe first. Okay, it's a storage controller basically. If you buy a new laptop today, most of the time you will see that you have a NVMe SSD. Okay, why it is NVMe? You will see it's very fast, and the read and write speeds are way greater than our normal SATA port. Okay, so basically what used to happen is, let's suppose this is the motherboard. Okay, and this is CPU, this is RAM, and these are PCI slots. And generally we used to have like a very big IDE connector, or we call it PATA in very old time, and then we had something like SATA ports. Then there are like SATA 2. So multiple ports came in picture, like 3 Gbps, 6 Gbps, like that. Okay, so now what we had to do is like, this is our hard drive. If we want to attach our hard drive to our computer or our system, we used to have a cable in between them. So the first time the cable connected, it was PATA, and then we have another cable like SATA cables, through which we can connect our hard drive to our PC or our desktop or server. Now these hard drives used to be magnetic in nature. So they had limited read and write speed, and the cable transfer was fine. Then came in SSDs. Okay, solid state disk. Now these solid state disk, they are way faster than our normal hard drives, magnetic hard drives, and we see that the limiting factor here was becoming this cable. Even though the connector speed was 6 Gbps, still my hard drive was not performing at its maximum due to the cable restriction. So what they do is they developed a new port, so that is called NVMe. It's a non-volatile memory express. Express for PCI lanes. So we have PCI Express lanes. So that's why E is there. So what they did is, now instead of connecting the hard drive via cable to motherboard, they created a card type structure and place the hard drive in it, and they insert this card directly into the slot here on the motherboard itself. So now there is no cable in picture, and my hard drive can directly attach to the motherboard. It is now much faster than the previous standards. So that's why it's the NVMe. Now it's a hardware feature in physical world. till hardware version 14, we do not have the capability to use NVMe in virtual machine. Now, because in hardware version 13, NVMe has been introduced, now I can select my storage controller as a NVMe controller, and my hard drive will work at the speed of NVMe. Sorry, the controller will work at the speed of the NVMe standard. Generally we can place the hard drive onto it, or they will create a very small NVMe controller port here on which you can attach a stick type hard drive. This is a newer standard now, and on most of the laptop you will see it's NVMe SSD wherever you are using a very high performing laptop or a workstation. Okay, so that is the NVMe adapter or storage controller. Is it clear what is the NVMe?
Yes.
This will be a kind of export which will be there in the laptop, and we can connect
Yes,
internally to work.
right. On the motherboard itself, there is a port. NVMe port, we normally call it.
Okay.
Okay. And once you connect your hard drive, it will generally perform much faster. Let me see if I can find a picture or two of this. Yeah. Generally, it sees like this. So it's a stick-like drive which you will find, and yeah, you can directly attach it on the motherboard. It's similar to a very RAM stick. Okay, and this here pins are the NVMe connector pins. You will just directly push it into the NVMe connector and it will attach on the motherboard itself. Okay. Now, because this is a hardware feature, right? But this particular hardware has been introduced in the virtual machine itself. Now your virtual machine can work as a physical machine. Okay, because this physical standard is there in the virtual machine itself.
Sorry,
Okay,
I
So
got
one
confused. So
question.
there is
yeah, one by one, yeah.
Yes. Yes, so one question, let's say if we select the NVMe port on the hardware thing, and so how really our real hardware is connected by, like, if that the real hardware is connected through SATA means the storage.
Then
So
there is
how
no benefit because you will be limited by the physical. But this is helpful in the cases where you are using SAN storage. So nowadays we are having the all flash SAN storage, right? And those are very fast storage. Means they can handle IOPS in the more than 50,000 IOPS in a single go. So if you're using that storage and then you are using this NVMe, it's very helpful in creating very fast vSAN. Okay. But if you are using this on your laptop, then unfortunately, no, it will not be much helpful in that particular case. Okay. Um, does this clear your question?
yeah.
Okay. Um, any other question?
yes, I was about to ask. Like you mentioned that there is this NVMe can be connected to virtual system itself. What that mean? System will be hardware always called physical, right?
Okay. So what do I mean by that is now if I go to this one, so let's Okay, so this is a virtual machine here, right? And let's see, this is, yeah, this is VM version 10. Okay, so core-01A is VM version 10, whereas app-01A is VM version 14. So let's see what's the difference between these two. Okay, so it is giving me the NVMe controller option, but device not supported error on the top. Okay, means I cannot attach a NVMe controller on a version 10 device because it is not supported. Why? This feature was introduced on hardware version 13. So either I need to increase its hardware version to 13 or more.
Okay, okay.
Now if I go to here, so as you can see, the app-01A is VM version or hardware version 14. So the NVMe controller got connected. Okay. So now once the NVMe controller got connected, I can attach my hard drives to it. You see here this new NVMe controller, new NVMe, click OK. Now, I do not have a physical NVMe controller on my physical hardware, alright, but still I am able to attach a hard drive to NVMe port in my VM. So that is the benefit of virtualization. You do not have the physical hardware for it, still you are able to use those features in your virtual machine. Okay, as you can see, there is this NVMe controller and my hard drive 16 GB is attached to a NVMe port on 00. Okay, I hope this is much clear now.
Yeah.
Okay, so let's move forward. So this is the NVMe adapter. It's a physical standard, but it has been introduced in the virtual machine, so I can use it in now VMs as well. Okay. Similarly, I have one more feature which is called RDMA, or we call it PV-RDMA. RDMA stands for Remote Direct Memory Access. So what does this mean here is, so let's suppose this is my system on which there is CPU and there is RAM. Okay. Similarly, I have one more system in which I have CPU 2 and RAM 2. Okay. Now, if we do the normal clustering, this CPU, can this CPU write directly on RAM of system 2? Means CPU 2 can write instructions here, that's fine, but can CPU 2 write instructions directly on RAM of system 2 in the normal clustering if we combine these two systems?
No.
Right? In the normal clustering, it is not possible, but there is something called HPC, high performance compute clusters. Okay, what they do is they have a special network adapter called RDMA, okay, through which these two systems are connected. All right. And what does this do is, now my CPU can write directly on RAM of system 2. Similarly, CPU of system 2 can write directly on RAM of system 1. They completely bypass the operating system. Okay, this is essential for if you want to create a very high performance compute clusters, like you are churning a lot of data, you want to do some very large calculations, then these type of clusters we make in our physical world. Now this RDMA is a physical standard. Okay, now if I want to create these HPC cluster in VMware in virtual machine, it was not possible. Why? Because this RDMA, which is a prerequisite for HPC, which is required to create HPC cluster, was not present in the VMware world. Okay, but now this has been changed. So starting with the hardware version 14, oh sorry 13, we have called PVRDMA adapter. PVRDMA stands for Para Virtual Remote Direct Memory Access. Why we call it Para Virtual? Because to use RDMA, the physical RDMA port is required. Means if you do not have a physical RDMA port, it might not function properly. So that's why it is called Para Virtual, not completely virtual. Okay, whereas in case of NVMe, we had seen that we do not require the physical NVMe adapter to be present on the machine. Okay, it was completely virtualized, but this RDMA port is para-virtual. Okay, so this has been enabled through hardware version 13. The main reason being so that we can create high performance compute clusters or HPC clusters in VMware as well. So that is called PVRDMA. Is this clear?
So this needs another port, the PVRDMA, in order
Yes,
to make it work and write on the second RAM for the system number 2.
right. So we will need a real port in the physical world so that it can work perfectly.
Okay.
Okay.
This
If there,
doesn't this
yeah.
please
Okay.
tell.
Okay, so basically if you have two VMs, okay, there are two virtual machines running on the same host, all right, then if you do not have a physical RDMA adapter, then it will work perfectly, no issues. But if you have two virtual machine, something like this. So let's suppose I have this ESXi here. So I have virtual machine VM1 here and I have VM2 here. So if I create the RDMA adapter on these two ports, now they will talk to each other by themselves. So there will be no network going out of the ESXi host into physical world. So this will work. But let's suppose I have another ESXi host on which there is a VM3 and this also have the RDMA adapter. Now I want to combine these 1, 2, 3 together. Okay, now 2 will send its traffic through ESXi host because anyhow these are virtual machine. They will if they want to talk to each other, they need to send their traffic to ESXi. ESXi will receive the traffic from the PVRDMA. It will send. Now there is no compatible RDMA adapter, so this traffic will get lost. It will not be able to travel through ESXi1 to ESXi2 so that it can be delivered to VM3. That's why we need the RDMA adapters in physical world so that they can talk to each other. Is it clear now?
So then RDMA port is the physical port on the ESX servers?
Right. Yeah, it's a separate port. So it's just like a network port, but it is different.
Yes, that's clear.
Okay.
Yes, it's so it's another cable but connected to
Yes.
SXIs, like we mentioned yesterday about the network traffic. Another
Right.
cable is this. Okay.
Yeah.
Now I get.
So generally we use Cat 5 or Cat 6 cables to carry our LAN traffic, or we have fiber cables as well to carry the storage or the 10 Gbps network. So these are RDMA are different cables, and one of the example of them is InfiniBand. So InfiniBand is there to create such kind of network. Not sure if I will be able to find some pictures of it. Yeah, you see this here. So
Yes.
this InfiniBand. So these are the Infini ports in which those cables get connected. So these are different ports. Okay, so this is the physical hardware which will get installed. Okay.
All right. Thank you. Thank you.
Okay, I have uploaded the PDFs, so you should be able to find them in the materials and you should be able to download them. Okay. So CPU, the maximum virtual CPU that you can attach on a virtual machine is 128. But you need to remember one thing. The maximum virtual CPU on a VM cannot exceed the logical CPU on a host. What do we mean by this is, so let's suppose this is your ESXi host. Okay. In my ESXi host, I have two sockets in which I have quad core CPU. So I have installed a quad core CPU here with HT. Okay. Now I want to create a virtual machine here. So I need to assign vCPU to it. So the maximum number of vCPU that I can assign is 128. Okay. But in this case, I cannot assign the 128 CPU because it will exceed my logical CPU. So how do we calculate logical CPU? Is equal to number of socket into number of cores into 2 if HT enabled, or 1 if no HT. Okay, so this is the formula that you have to remember. Logical CPU, we can also call it as physical CPU on the ESXi host. So in our case, what is the total number of logical CPU here is? So number of sockets are 2. Quad core CPU means number of cores are 4. HT is enabled 2. So it will be 16. So the number of maximum vCPU that can assign on a single VM is 16. This cannot exceed 60. So you need to, this is a key point which you need to remember. Okay, I can create a second.
Sorry, can you explain again the how to calculate the size?
Sure, I will let you know. Okay, so first VM 16 CPU. I can create a second VM with 16 CPU, but a single VM cannot exceed the total number of logical CPU. Okay, now how to calculate the logical CPU? It's very easy. Just remember number of socket into number of cores into 2 if HT is enabled. If there is no HT, multiply it by 1. Okay, so number of socket is basically this thing. This here. This is called a socket. The if you open up a motherboard, you will find that your CPU is placed inside a holder or socket, right? So that particular thing is called socket. So sometimes there are two points to place the CPU. So this is dual socket motherboard. Sometimes there are 4, so that are quad socket motherboards. Okay, so socket is the physical placement or the physical fixation of the CPU into the motherboard. Okay, so you need to take the total number. In our normal desktop, it is single socket, means there is only one socket. So in my case, there were 2 sockets, so I write 2. Now you need to find out what is the core count of your CPU. You might be having dual core, quad core, hexa core, octa core, okay, 16 core. So in our case, it is quad core, so I write 4. Okay, now I said it's with HT. Let's say it's without HT. Okay, then this point will become 1 and the number of total logical CPU will become 8. Okay,
So what is HT in that one? Like so
HT
what is
is
like?
hyperthreading. Hyperthreading means a single core can process 2 threads instead of 1 thread. So if no HT is, means if HT is not there, then a single core can process only 1 thread, and if HT is enabled, so a single core can process 2 threads. So that is the benefit of HT. So that's why either it's 1 or 2. Okay. It's a CPU hardware feature. Generally, all the means Intel and AMD CPU comes with HT enabled, so that you can check it from the CPU datasheet. Okay. Now, because our logical CPU count here become 8, so the maximum vCPU that I can attach on a single VM here now is, it will be also become 8. Okay, that doesn't mean that I cannot create a second VM. I can create a second VM and provide 8 CPU to the second VM as well. I can create a third VM and I can attach 8 vCPU to third VM. I can create a fourth VM and attach 8 CPU to it as well. But the maximum number of vCPU to a single VM cannot exceed logical CPU. So that is a key point. Okay. Any doubts?
Thanks. Earlier, how that 128 comes up? That
128 is the maximum limit.
Okay.
Means a single VM cannot have more than 128 CPU.
Okay, got it.
Yeah, so it's in the single. So in this case, current case,
Yeah.
Let's say our logical CPU is come to 8. So how many VMs I can create with 8 CPUs maximum? So how many VMs? And how that one is possible? Let's say the 8 of means 8 vCPUs are assigned to one VM. So I can create another multiple VMs with 8 CPUs, vCPUs. So how that is related to, like how it is possible?
Okay. So basically, there is no limit on the number of virtual machine. You can create any number of virtual machine, but generally, uh, what we do here is the CPU is not utilized 100% every time, right? So that's why we have a thumb rule, you can say, means over the experience that I have seen. So let's suppose you have a very high intensive application, so your utilization is going to be 100% used. So we take it as pCPU to vCPU ratio. So generally we take it 1 to 1. The best example can be a SAP application. Okay. Now, if you have a production environment, okay, where the CPU utilization revolves around, let's say, 40% to 60%. Okay. In that particular case, we can take something like 1 to 2 or 1 to 3, something like this. Means one physical CPU can handle 2 or 3 virtual CPU. If it is a QA, we can increase the number. It can go till 1 to 4, 1 to 5. If it is VDI, it can go till 1 to 9, 1 to 10, something like that. Means there is no limit. It's just uh, you can say the experience over the experience that I have seen that these settings normally work fine without any issues. Okay. But yes, there is no limit. As long as your VMs is not getting slow, you can provision more VMs. That's the thumb rule is. Okay. So again, storage, I have already told you about like the NVMe controller. Now, apart from NVMe, we have other controllers as well, like bus logic parallel, LSI logic parallel, LSI logic SAS. So all of these controllers, as I have told you previously in the last class, that you have to select the correct guest operating system. If you have select the correct guest operating system, these storage controller will be selected automatically for you and they work perfect. So if you're sometimes we see the issue that I am installing operating system and I'm not able to find the hard drive. That is why one of the reason can be because the storage controller has been selected incorrect. How can it happen? You have selected the guest operating system 2003 and you are installing 2008, 2012, or you have selected 2008 but you are installing 2000 or 2003. So these things can create issues. So make sure that the correct guest operating system is selected. So we have discussed about we haven't discussed about the virtual disk. We only discussed about the file types. Okay. So in the VM world, we can provision 3 types of disk: thick, thin. Okay. Uh, so what is the difference between these three? So let's take thick and then thin. In thick, reservation is equal to allocation. whereas in thin, reservation is equal to usage. Okay, so what do we mean by reservation, allocation, and usage? So let's suppose you have a storage data store of 100 GB. Okay, now you have created a VM and assign a 50 GB hard drive to it, and it is thick. Okay, so what will happen? The total allocated size of the hard drive is 50 GB. So 50 GB will get reserved for my VM1. No other VM will be able to use it. Okay. Even though, so inside the hard drive, only 10 GB data was written. So this 10 GB is called usage. So the 50 GB is the maximum size of the hard drive, or I can say that the total amount of data that I can write inside the hard drive is 50 GB. Okay, so that is called allocation. How much data I can save in my hard drive. Okay, so in thick provisioning, the reservation is equal to allocation. So whatever the size of the hard drive, it will get reserved for it. Okay, now let's suppose I created a new VM2 with again 50 GB hard drive, but now it's thin. Again the same case, only 10 GB data was written. Okay, now in this case only 10 GB of space will be reserved for VM2. Okay, means in rest of this 40 GB space I can create another VM with another hard drive. Okay, so I can create a VM3 with 50 GB disk, and let's suppose it's 20 GB data is being used, so the total space that is reserved is 20 GB. Still 20 GB is free. But now you need to remember one thing, that the total size of the hard drive is 50 GB. If you means this VM2 can ask for 40 GB more from the storage. Let's suppose it asks for 40 GB more. Now how much space do I have left on storage? 20 GB. So what will happen? This VM will get crashed as well as this VM. Okay, because there will be no further space to write on the data store. Your data store will get full, your VM will get stuck, and they will get crashed. So if you are using thin provisioning, make sure you are continuously monitoring your data stores that they are not getting full. So this is the basic difference between thick and thin. Is this clear? Any doubt till this point?
Yeah, Vinay, repeat the first one, thick one again, one more time.
Okay. So the thick is thick in the thick provisioning, your reservation is always equal to allocation. So let's suppose you have provisioned a 50 GB of hard drive. Means while creating a VM, you say, okay, I will attach a 50 GB hard disk. Okay. Now, while attaching this 50 GB hard disk, you mentioned it will be a thick provisioning. So what will happen on the data store? All the 50 GB will be reserved. Let me show you with the help of an example. Okay, so let's check. So I have one data store with me. It's reason A01-SCSI comp01. Right now the free space is 40 point something GB. Okay, so what I will do, I will create a new hard drive. Okay, and I will mention it as 20 GB, but I will select it as thick provision. Okay, so I have selected as thick provision and I will click OK. So the disk has been provisioned. Now let's check the space left on the data store. As you can see, the free space left now is less than 20 GB. Sorry, it's 20 GB only, because 20 GB I have given to my hard drive. So have I write something on the hard drive? No. But as soon as I created the hard disk, the whole space in the data store is reserved for that particular hard drive. So this is called thick provisioning. The reservation is equal to allocation. So in our case, allocation was 20 GB. So data store reserved 20 GB straight away for the hard drive. Now let's create another hard drive of 20 GB, but this time we will keep it as thin. I will create a 20 GB hard drive and I will keep it as thin. Okay. Another example can be, right now see the maximum size here is 20.63. Okay. If I do it 40, okay, it will not let me create. So there is a check in place. Okay. So I will keep it as 20 and okay. So I have created a 20 GB hard drive more, but this time I created it as thin provisioning. Now let's see what will happen to our data store. As you can see, there is no increase in the space because I haven't saved any data on the 20 GB hard drive. So in thin provisioning, your usage, your consumption is what becomes reservation. So basically, if I start writing any data on the hard drive, it will start saving it in the data store and my data store will start getting full. Okay, is it clear now?
Yes, it's good. Thank you.
Okay.
Yeah. So also now again, if you create another hard disk, will means we are able to create that hard disk, or it will give us error that already it has been full?
No, you will be able to create it. So let's go there. The app 01A. Edit settings. Let's create one more. I'll try 20 and let's keep it as thin. So it's completed, and if I go, so you can see it's not getting more. Okay, all right. So you can create
Okay.
any number of hard drives, but the problem here is you need to keep monitoring the data store if you are doing the thin provisioning, because what you have done now, you have given 40 GB of storage to your hard drive. Okay, but the free space is 20 GB. So let's suppose you start using those hard drives, your operating system will say I have still 40 GB to use, it will keep on using it, but your actual storage, the physical storage, does not have that much amount of free storage. So what will happen? At the end, the whole data store will get full. Your operating system still wants to write more on the hard drive. Your data store will say, I cannot, and there will be a clash and your VM will get power off. Okay. So this thing we have to monitor in the thin provisioning. Okay. So the difference between thick and thin is clear, right? Any doubt in thick versus thin?
Very good.
No.
Okay, thank you. So now in thick provisioning also there are two types. One is called eager and another is called lazy. Okay. So what is eager zeroed and what is lazy zeroed? So let's look at that. So this is my hard drive. So generally there are blocks in which the data is written. So let's suppose I have to write this data 1010. Okay. So before I write any data, there is a process called zeroing. Okay. Means before I start writing any data, I need to write all 0. So let's suppose I want to write 1 first. Okay. I want to write 1. So the first cycle 0 and second cycle 1, means first it will write all 0. So 4 cycles have been completed to write 4 zeros. Now in the second cycle it will start writing the data. So how many cycles do I need? 1 0 skip, 1 0 skip. So 2 cycles. So basically this is how I write my data on the block. So this is very layman terms. Okay. So what is happening? First I need to write all 0 and then I can write my data. If it is 1, it will write 1. If it is 0, it will skip. Okay. Now this zeroing process, this writing all zeros, this is where the difference comes in between the eager and the lazy zeroed. How? In the eager zeroed, when I am creating a new hard drive, at that time it will write all the zeros. Okay, write 0 at time of creation. Okay, whereas in lazy zeroed, it will write 0 at time of actual data written. Means when I'm actually saving my data or when I'm actually writing my data on the hard drive, at that time it will write 0. So what's the difference between these two? In eager zeroed, how many cycles will I need to write 1010? Only 2 cycles. Why? Because all the zeros have been written. Okay, I do not have to write all zeros again. So I will need only 2 cycles to write this data 1010. Whereas in lazy zeroed, I will need 6 cycles. Why 6 cycles? Because first it will write 0 and then it will write data. Then 0, then data, then 0, then data, then 0, then data. So 2 cycle versus 6 cycle. So this is the difference between the eager zeroed versus lazy zeroed. So wherever we are creating a SQL database or high performing hard drives needed, we go for the thick eager zeroed. Okay, so any doubt between these two?
It's a question.
Yeah.
So both of them, eager zero and lazy zero,
Yeah.
have the first step that writes zeros.
Right.
Okay. And then, based on the time, the system searches where it is zero and make it so on.
Yeah.
With
So
data.
right. So in both eager zeroed as well as lazy zeroed, the first step is to write 0. But at what time I am writing those 0 is matter. In eager zeroed, whenever I am creating a new hard drive, at that time it will write all zeros. So your creation of hard drive will be slow. Whereas in the lazy zeroed, when I am writing data, at that time it will write 0. So let's see. So let's go to the lab. Okay, so right now you all had seen that I had created one thick eager zero drive and how fast it was created in couple of seconds, right? So what I will do, I will create a new hard drive again and I will keep it as 15. But this time I will select, instead of thick provision lazy zeroed, I will select thick provision eager zeroed and click OK. Now see the task here. It's taking some time, right? While creating the hard drive, it's taking time. Whereas previously it was completed like in a matter of second. So why it is happening? Because the time it is creating the hard drive, at that time it is writing all the zeros beforehand, so that I can only write directly data. I do not have to write zero again and again. So that is the speed difference between these two, thick eager zeroed and thick lazy zeroed.
Okay, understood. Thank you.
Okay, no problem. Okay, so this is again the thick versus thin. Yeah, so as you can see in the creation time, thick provision lazy zeroed is fast, thin is fastest, whereas eager zeroed is slow. Okay, and if you see the zeroing of the allocated blocks, file blocks are zeroed when each block is first written to, means whenever you are saving your data, at that time it will write the 0. But file blocks are allocated and zeroed out, means the whole disk when it is created, it is already allocated as well as zeros are written. Okay, so networks, we already discussed about networks, like how to select the correct network. Generally, we select it with the help of the operating system. So as soon as we select the correct operating system, it will select the network for us. Okay, okay, and there is just one important point I would like to highlight here, that is the SRIOB. So what is SRIOB? It's the pass-through. So what is happening here is, so let's suppose this is my ESXi host. There are two physical NICs. These physical NICs are connected to a switch, and then there are multiple virtual machines. Okay. So how these virtual machines will be connected? There will be something called virtual switch is there. All the virtual machines are connected to virtual switch. And these uplinks are connected to virtual switch. And so basically all the traffic that is being sent by virtual machines is managed by virtual switch and then sent to the physical NICs. Okay. Now these are VNICs, these are PNICs. What is the problem in this scenario is, let's suppose here these NICs are 1 Gbps, okay, but you have created here 10 Gbps NICs. Okay, so basically all the 50 VMs can send traffic at the speed of 50 Gbps. So what will happen, all the 5 virtual NICs will have to share the bandwidth with them, right? So all the 5 virtual machine will be sharing bandwidth of 2 Gbps. There are 2 NICs of 1 Gbps, so total bandwidth will be 2 Gbps. So all 5 virtual machines are sharing bandwidth. So sometimes you can see bottleneck if it is not properly designed. Now this is a very critical VM. This VM here is critical, and you want to ensure that it is not impacted at all. Means this VM should not share any bandwidth. So what we can do in this case is, there is something called SRIOV. Means instead of managing this link through virtual switch, I will remove this and I will attach my virtual NIC directly to my physical NIC. So all the traffic coming from the virtual machine will be sent directly to the switch. Okay, it will now not be managed by the virtual switch. So this is called SRIOV. Okay, so this is a very good feature, but it has certain restrictions, like we cannot perform vMotion and certain other restrictions are there for the SRIOV. So that's why it is only used for the most critical VMs. So any doubt?
Yes, because I lost it on the diagram that you made. What's the first box below the VMs? What have you written there? What's that? I don't get it. Sorry, I cannot understand it.
Okay, all right. Okay.
The S key is connected to something and then to VMs. This is the one.
Right. Okay. Let me make a little bit clear diagram. Okay. So basically, this is a virtual switch. Okay. Now these are my VMs. And these VMs are connected to virtual switch. Okay. Now virtual switch is generally is managed by the ESXi host. So this virtual switch something will be like this. ESXi. Okay. And I will have the physical NIC here, and these physical NICs will be connected to virtual switch. Okay. Now these are VNIC and these are PNIC, physical NIC and virtual NIC. Okay. And I will have a switch here, which is a physical switch, and my physical NICs are connected to physical switch. Okay. Now what I mentioned is that all of these 4 VMs are connected to virtual switch, and these virtual switch are connected to physical NIC. So what is the total bandwidth of this virtual switch? So let's suppose these physical NICs are 1 Gbps in nature. Okay, so the total bandwidth will be 2 Gbps. So all the 4 VMs here will need to share that 2 Gbps bandwidth. Okay, now What I did here is that the VM1 or the first virtual machine is a bit critical VM. Okay, I cannot share the bandwidth for this virtual machine. So this VM1, it's a critical VM. Okay, I do not want to share any bandwidth. So what I do is I can directly attach. Okay, I will remove this link and I will attach my vNIC or virtual NIC directly to my physical NIC. So no bandwidth will be shared by the virtual machine one. It will directly send its traffic to the physical switch through physical NIC. So this process is called SRIOB. Is it clear now?
Yes, much better. Thanks a lot.
No problem. Okay. Any other doubts?
Yeah. So how much capacity this critical VM going to consume?
Sorry, how much?
How much that we have 2 Gbps RAM, right? Sorry, CPU. So that critical VM1, my question basically, how much is going to use the both 2 Gbps or
No,
how
it
much
will be 1 Gbps because you will attach one NIC to one physical NIC. So physical NIC is of 1 Gbps, so it is going to use the whole.
Okay, and the remaining other 3 VM going to share 1 Gbps, right? Not 2.
They will share, yes, but they will be sharing among themselves. But this VM1 will get the topmost priority, so it will have the dedicated PNIC basically there.
Okay, so other 3 VMs is still going to share the 2 Gbps.
Right.
Okay.
Okay. Okay. So next comes the direct path IO. So direct path IO is something similar, but it is used for the graphic card or the PCI slot basically. And PVRDMA we already discussed. So this SRIOB means attaching the VNIC, the virtual device, directly to the physical device. We can do it for the graphic card as well. So it can be graphic card, it can be USB, it can be PCI slots. Okay. So all of these options comes under direct path IO. Okay. So if we are connecting virtual NIC directly to physical NIC, it will called as SRIOB. But any other device you are connecting directly, like graphic card, USB, PCI slot, or it can be a CD DVD drive, it is called as direct path IO. And then we can have other miscellaneous devices like CD, DVD, floppy, virtual GPU, console. So we already like yesterday created the virtual machine and like checked how to take the console. So it's like to interact with the virtual machine, you need to look inside the virtual machine, then you can take the console of the virtual machine. So this completes our topic of virtual machine creation. So any doubts related to the creation of virtual machine or any other previous doubts? Okay,
No, I think.
all right. So it's 8 o'clock my time. So let's take a quick 5-minute break. I will have some water and I will catch you guys. All right.
All right.
So we
Okay.
will meet at 8:05 my time. Okay, in 5 minutes. Okay, guys. So should we start now? Hello. Okay, thank you, Arvind, for the confirmation. Okay. So the last step, the last lesson that we have left with is the virtual machine management. So we are going to cover the snapshots and the vMotion, like what are the benefit of these two features, and what is the use of these two features. So let's look at the snapshot first. Okay, so what is the purpose of snapshot and how to work with snapshots? Okay, so I will ask everybody to be ready with your labs, because this is a little bit uh, heavy on the lab. So we will do a side-by-side practice on the lab as well. Okay, so let's cover a little bit theory on the snapshot, and then we will take it on the. So what is snapshot? Let's suppose that you have a mm, let's say, okay, let's suppose you have a healthy database. Okay, so you have a database server up and running, and you have a backup at 11 a.m. Okay, then what you did is you take another backup as 12 p.m. Now at 1 p.m. your application team starts to upgrade their application, which makes some changes in the database. Now they upgrade the application, and after 1 hour they come to know that at 2 p.m. the application upgrade has got failed. Now you need to revert the state. Okay, so basically, but you have the last healthy backup of 12 p.m. only. So now you need to restore the whole state. Okay, whole database from the 12 p.m. backup. So any wild guesses of how much time will it take?
Take depending on the size of hard disk, right?
Right, it will take like what is the backup size, what is the backup medium. It can take couple of minutes, or it can take couple of hours as well to restore the healthy state, right? And then to continue the operations. Okay, this is where the snapshot comes in. So basically what happened in snapshot is uh, I have a healthy state of the VM running. So let's suppose at 1 p.m. my application team informs me that I am going to start the activity. So at 1 p.m. what I will do, I will take a snapshot. Basically, I will capture the healthy state of the system. And let's suppose at 2 p.m. they told me that the application upgrade has failed. So I need to revert the state. So what I will do, I will simply revert the state back, and it take only seconds to revert the state. So this is the benefit of using snapshot. Within seconds, you can restore your healthy state of the system. So is snapshot, like function of snapshot is clear? What snapshot is doing?
Yes.
Any doubt
So
related to snapshots? Yeah.
yeah, so snapshot basically is just like backup only, right? What is the difference?
No. Snapshot is not a backup. Basically, snapshot captures the healthy state of the system. It's a point in time. You can capture the state. Okay. Backup is like saving all the files, saving all the states to a separate medium. It do not do that. Basically, it will
So
put a marker in time. Okay. So this is the healthy state. It will put a marker. Once you are ready to restore or ready to revert, you will simply move all of your the marker that you have put there. You will revert to that particular marker, and all of the healthy state will be revert. Yeah.
okay, so where basically this marker or the snap store
Yes.
the
Right.
status?
Yeah. So that will be under the working of the snapshot, which will be coming next. So I
Okay.
will be discussing that. So apart from that, any other doubts? Okay. So now let's look at how snapshot works, or how this a revert of healthy state is possible within seconds. Okay. So remember, we yesterday we discussed about certain files like flat.vmdk. Basically, this is the file which save all of our data, right? So generally what happen is this flat.vmdk is a single file. Okay. I
Vinay,
can
you sharing anything?
oh, sorry, I forgot to show my screen. I'm really sorry about
Okay.
that. Okay. Is the screen visible now?
Yes, yes.
Okay. So yeah, so like I was saying, yesterday we discussed about a file called flat.vmdk. All right. Now generally what happened in flat.vmdk, all of my data is saved. Okay. Now this is a flat file in which I can write my data continuously. Okay. Now taking the previous example that okay, I am doing the application upgrade. So if I am writing any of the changes, that will be a straight line change, means all of the blocks that are saving, it will write all of the data in it. Okay. And if I want to take any backup, I will take the backup of the files, or in the traditional medium I would have taken the backup of the files, save them somewhere else, and if I want to revert it, then I would have copy back those files back to my original system. Okay. But this has been changed by the snapshot. So what happened in snapshot? So this is your flat.vmdk. Again, all of the changes are being written in the flat.vmdk. So, right now, what you did is at 1 p.m., your application team told you, okay, I am going to perform some changes. So, 1 p.m., you put a marker. Now, what happened at 1 p.m.? As soon as you take a snapshot, your flat.vmdk will be in the read-only mode. Okay. And a new file will get created which is called delta.vmdk. Generally it follows a very large name like 0000001 hyphen delta.vmdk, like this. Okay. Now because flat.vmdk has been made a read-only copy, so all the new changes after 1 p.m. will be written in delta.vmdk. Okay. and at 2 p.m. so your marker is here right now. At 2 p.m. your application team told you that okay, my upgrade has been failed, so I need to revert the state back. So what I will do, simply I will just put this marker which is here. I will put this marker and again put it at the flat.vmdk. Now all the changes were saved in the delta, so those changes will be removed and I will have my original state, original flat.vmdk back. Okay, so this is how the snapshot actually works. Does this clear your question?
Yes. So how many snapshot we can have? Let's say we have multiple, like hundreds. How we can go any back snapshot?
Yeah, so you can have as many number of snapshots as you want, but the problem with the snapshot is they are space consuming. I will be coming to this point later on, how they consume space. But okay, let's suppose at 2 p.m. the application team says, okay, uh, our first part of the upgrade is successful. Now we want to capture the state of this 2 p.m. so that we can start with the second phase, so that in case we want to in case of any failure, we do not have to start the whole process again. So what I will do, I will at 2 p.m. I will take another snapshot. So this delta.vmdk, again it will be in the read only mode, and there will be another delta file which will get created, and all the new changes after 2 p.m. will be written on this new delta file. It will be something like this: 000 002 hyphen delta.vmdk. Okay, so in case of any issue, you can simply now revert to flat.vmdk, okay, for your original state, or you can revert to 0001 delta.vmdk for the first successful update of the application. Okay, so as you can see, you can create chain of snapshots. That is very much supported. Any doubt till this point?
No.
Yeah, snapshot is nothing but the backup of that VM, right?
No, it's not backup. As you can see, I am not creating any copy. What I am doing is I am just keeping my original file in the read-only mode, and I am creating a new file and I'm writing all the changes in the new file. So it's not a backup basically.
So after completing the after let's say completing the changes,
Mm-hmm.
so after let's say 2 p.m. What will happen to the flat.vmdk? Like whether that existing changes will be get copied to new thing, or uh, it will keep the delta one to the
Right.
flat.vmdk.
Right. Uh, so that will be the part of the just after this I'm going to discuss the drawback of the snapshot. So we will be discussing these points like what will happen to delta, how do we commit the changes. I will discussing these factors in a couple of minutes. All right.
Okay.
Yeah. Okay. So any doubts like how the snapshot is working right now? So any other doubts you want to ask? Okay. So what I will do is now, so let's first look at the lab, okay, and then we will discuss these how to commit the changes or how to revert the changes, okay. So it will be very much easy to understand. So everybody is with their ready with their labs.
Yes.
Okay. So there is a machine called Win10 in VCSA-01P. So We will open the console for this particular VM. We will use the web console. To log in inside the VM, again the password is same, capital V, capital M, small WARE, 1 exclamation
Sorry,
mark.
Vinay, first we need to log in into that, right? We need to connect. We need to enroll again, right? Something.
Right.
Which one? This system?
It's the same, the last one. It's HOL-2011-91-STC.
Okay.
Okay, it's HOL-2011-91-STC. VMware vSphere Lightning Lab.
Can we access this VMware when we finish these classes? This class? I mean, can we access it again and do it
Yeah.
once again? Okay.
Absolutely, yeah. That is absolutely free of cost. So you can log in as many number of times as you want. And this is not the only lab. If you want to explore any other labs, you can do it as well. So there is a manual right in the lab itself. So just go through the manual and it will guide you through the lab as well.
All right, thank you.
Okay, so is everybody with the lab?
However, yours has IP and DNS. Mine doesn't have. Your VMware Windows 10.
Okay. Sorry, it was Theo or Fortis?
Yes, Theo.
Yeah, Theo.
Yes, your Windows 10 unit has DNS and IP address, but that doesn't have mine. Mine doesn't have.
Okay. Are you in
This
the
is
right
normal.
lab?
Yes.
Okay. Can you try to expand this? Are you able to see this vcsa-01b.corp.local?
Yes, that's correct. I'm there.
Yeah.
I'm
Okay.
on the last machine that has on the bottom.
Yeah. At the bottom, it's Win10, right?
Yes, that's correct.
Okay. So just take a click on the Win10, okay, and you will be able to see Launch Web Console. So click on the Launch Web Console. It will give you a prompt, Web Console, and click OK, and it will launch a console. All right, like this one here. If it is
So,
fast,
I did
so
it. Yeah.
Vinay, what user ID password we going to use?
so it's the same. It's
Root?
the same password. No, not root. In Windows, it will just prompt you for the password. Then you need to type in the same password, capital V, capital M, small WARE, 1 exclamation mark.
On user ID?
User ID, it will automatically take as administrator at corp.local.
For some reason, it's not showing for me.
Okay.
So I'll use that administrator at corp.local.
Right. So you can open up the readme dot
Yes, yes.
text file, and it's there, administrator at corp.local. Copy paste unfortunately will not work, so you need to type in manually.
Okay, thank you.
Okay, so this is a Windows 10 desktop. Just let me know once everybody is on the same page and we will start.
Yeah.
Okay, thank you. All right, so let's start now. So what we will do, we will be working with the snapshots. So what we will do, we will create some chain of snapshot and we will see how they affect each other. All right. So first on the desktop, create a new file. Okay.
I'm sorry, so from the previous, can you go back to your previous one? How to open this VM?
Win10.
Yeah, from there.
Just go to VCSA-01B. Okay.
Okay.
Explore all the way to the down, and on the bottom you will see a VM called Win10. Click on it. Then you
Okay.
will see the option Launch Web Console. Click on the Launch Web Console and it will give you a prompt. Just make sure Web Console is selected and click OK. And it will open up the console like this.
Yeah, thank you.
Okay. So on the desktop, first we will create a test file and call it snapshot1. So we will call it before snapshot1. Okay. So just press enter. So this is before snapshot1. So once everybody done, let me know. Okay. So at any point of time, if anybody is facing any issue, just raise their hands so that I can know if there is any issue or not. All right. So
So what we did now?
So we created a new text file on the desktop in Win10 desktop is before snapshot1. Okay.
Okay.
Now go to your vCenter server. Okay. We will right click on the Win10 machine. Once we right click, you will see third option as snapshots. Okay. There will be an option take snapshot. Click on it. Then it will ask you a name. So we will give the name as snapshot1. Make sure the snapshot, the virtual machine memory is unchecked. Okay, and then just click OK. So you have created your first snapshot. So anybody facing any issue? Everybody done?
So we can give any name, right? In the
Right. Okay. Now let's go to Windows 10. We will create a new text file again and we will give it name before snapshot 2. Okay. So once we have created the snapshot 1, we have created second file which is before snapshot 2. Now we will go there Right click again, same snapshot, and we will click on take snapshot, and we will give it name snapshot 2. Make sure the virtual machine memory is unselected, click OK, and another snapshot will get created. Now again we will go to desktop, Windows 10, we will create one more file, which is before snapshot 3, and go to vCenter server, right click on the Win10 and snapshots, and take snapshot, and we will give it name snapshot 3. Okay, now we will create a file called
One moment,
test file.
because it just completed the second snapshot.
Okay, no problem. So once the second snapshot is completed, go to your Windows 10 machine, create a file before snapshot 3. Okay, once before snapshot 3 file is created, you need to create a snapshot called snapshot 3. Once the snapshot 3 is completed, then you need to create a new file called test. So I will wait now till everybody is finished.
The third is getting created now. So the last file that we need to create is
Test file.
okay. Thank you. But we don't take a fourth snapshot, right?
No, we will not take a fourth snapshot. So let me show you on the screen what we have done. So we have Windows 10 here. We created a new file which is before snapshot 1. Then we take a snapshot which is snapshot 1. Then we created another file which is before snapshot 2. Then we created another snapshot which is snapshot 2. Then we created another file which is before snapshot 3. We created another snapshot which is snapshot 3, and then we created a test file. Okay, so this is the whole process that we have done right now. So please raise your hand if anybody is not done, otherwise we will move forward.
Just 1 minute.
Okay.
About this vSphere, is there any license that is given for a period of time, like a trial or something?
Yes, you can download the vSphere for a 60 days evaluation period.
All right. There's an extension of that, right?
Sorry?
The extension is paid. Then you go for a subscription, right?
Not sure. Basically, you can simply create a my VMware ID, And once you have a My VMware ID, you can like there are multiple products for you which you can download the evaluation version. So that work differently from the training basically.
Okay.
So even if you haven't purchased any training, you can still procure the evaluation version. You just need a valid email ID and some details, and you can get it directly from the VMware.
All right. Thank you.
Okay, so everybody done?
Yes.
All right. So as you can see, after creating the test file, our marker is here right now. Okay. And if we want to see it in the screen, in the lab, what we can do is we can right click on the Win10 and snapshots and manage snapshots. If I click on this, you will see I have Win10, I have snapshot 1, snapshot 2, snapshot 3, and then there is the marker. You are here. Okay. Now, so let's do a practice of how to revert the state. So let's suppose snapshot 1 is good, snapshot 2 is good, snapshot 3 is good. So this test is some change that I have performed and it is not going well. Okay, now I want to revert to the state of before snapshot 3, means I want to go to the state where only two files are present. One is before snapshot 1, another is before snapshot 2. So where I have to place my marker? I have to place my marker here, right? So that all these two changes are removed. So how can I place my marker here after snapshot 2? To place the marker here, we use something called revert. Okay, so how do we use revert? I will right click on the Win10, go to snapshots, manage snapshots. I will select where do I want to revert to. So I want to place my marker from here to here. So I will select snapshot 2. Then there is this option called revert to. Select revert to. It will ask current state of virtual machine will be lost. Click OK. And now you see the marker has been moved. Press done. Your virtual machine might be powered off, so power it up. So let's boot it up first and see whether we are getting the desired result or not. So it's loading, so we will see. So as you can see, how much time did it take for the revert? A second. In the production environment as well, it take only couple of seconds to revert the states.
Can I have something?
Sorry, yeah, please.
You may mention it later, but I show by clicking on the snapshots. The first one is 10 gigabyte, but the second and the third, it's much smaller. So somehow they are related to the first one in order
Right.
to go back on the snapshot that we have created after the number one, right?
Right, that's right. So all the snapshots are interrelated. You cannot delete one snapshot. Means you can delete the snapshot in between. So I will show you that process as well of how to delete the snapshot or how to commit the changes. But yes, all the snapshots are interrelated. So The parent file is the flat.vmdk, then we have delta 001. As we move down, all the above files will be related. Okay, so I logged in into my system Win10, and as you can see, there are only two files, before snapshot 1 and before snapshot 2. There is no file before snapshot 3 and test file. So those changes have been reverted by the snapshots. Okay, so if I see on the screen, so this test file has been removed and before snapshot 3 has been removed, and my marker is here now. Simply I can move my marker here as well. Okay, is this clear how to move the markers?
Yes.
Okay, now let's suppose that I want to revert to a stage that where before snapshot 3 is also present, means I want to move my marker to this here. That is also possible as well. Okay, means I can move my marker from here to here as well. So once I have a series of snapshot, I can easily go forward or backward in between them. Generally, it is highly discouraged because it can corrupt the operating system or the flat file. But yes, you can do it. Okay, but there is no way to restore this test file because this change was not saved under any snapshot. Okay, so this test file has been lost. Okay, so till this point, how to take snapshot and how to revert snapshot, these 2 points are clear.
Yes.
Okay, thank you. So now let's look at how to commit the changes. Okay, so this is my flat.vmdk. All right, now at 1 p.m. I took a snapshot. So there is another file which is 00001 hyphen delta dot vmdk got created. Then at 2 p.m. I took another snapshot due to which another delta file 0.0.0.0.2 got created. Then I took another snapshot which is 0.0.0.0.3. Okay, so my marker is here right now. So at this point, if I say delete, okay, so this is snapshot 1, this is snapshot 2, this is snapshot 3. Okay, now at this point, if I say delete, what will happen? It will commit these changes into the parent. Okay, so whenever you delete any snapshot, it will commit the changes to its parent file. So let's suppose you delete this snapshot 02, it will commit the changes to 001 file. If you delete this snapshot, it will commit the changes to the flat file. And if you press delete all, okay, all the changes which are present in the delta files will be committed to the flat file. Okay, and all the delta files will be removed. Okay, this bit is clear. Now,
Sorry, so how that going to delete? Sorry, repeat again.
delete is simple like just it will commit all the delta files to its parent file simply when you press delete. Okay, but you need to remember one thing: all the changes which are after the marker will be rejected, and all the changes which are before the marker will be committed. Means, okay, so let's suppose my marker is not here, it's my marker is, let's suppose, here right now. Okay, okay, if my marker is here, okay, so the changes after the marker, so the changes in the 2 and 3, these will be discarded. All the changes which are before the marker, so the changes in the 1, they will be committed. So we need to remember this. All right.
Good.
Any doubt?
Yes, just a question to confirm that. So if we delete the snapshot number 2 with the green marker, we lose the 3 and the 4, right?
Right.
Okay, so they are interrelated as you said earlier, and it's like a chain. If we lose one key of that, we lose it all after that.
Right.
All right, thanks.
Okay. So if we take it to our lab, so if I go here, so let's go to snapshot manager. So if I go to snapshot manage, now you see this marker, you are here. Now this marker is right now after snapshot 1 and snapshot 2. So the changes in the snapshot 3. So I have a file in snapshot 3 which is before snapshot 3. At this point of time, if I press delete for snapshot 3, I will lost the file. Okay, the changes will be discarded. Why? Because it is after the marker. But if I press delete snapshot 2, its changes will be saved inside snapshot 1 because it is before the marker. So you just need to remember this. So at this point, if I press delete all, you will see it will start the remove all snapshot command will start. It will take some time. It will not impact your VM. It's completed. Now if I go to Win10 snapshot, manage snapshot, I am not able to see any snapshots. So all the snapshots have been removed. Let's see what is showing on the desktop. As you can see, I can see only 2 files, before snapshot 1, before snapshot 2. I am not able to see before snapshot 3 file. Why? Because that file was after the marker. The changes was present after the marker, so those have been discarded. Here, so the marker is right here. Okay, so it is present here. So before snapshot 3, this file has been discarded because it was after the marker. So this is the thing that you have to remember with the snapshot when you are deleting the snapshot. Any doubt? Okay. So now we will see why snapshot can be a bad thing. Now, let's suppose your flat.vmdk is of 100 GB. Okay. Now, at 1 p.m. when I take a snapshot, this flat file will be what? Read-only mode. So your 100 GB is logged. Now, a new file is created, which is a delta file. Let's suppose you performed some changes in the delta file. Let's suppose you write 10 GB of data. Okay, then again you take a new snapshot, so your delta file is also locked. Then in the second file you performed again some new changes. Let's suppose you performed 50 GB of changes. So all the changes are new data to my snapshot, so it will save all of those changes in the delta file. Then again you take a new snapshot, so this file is also locked. And then you start modifying or performing new changes on your third snapshot in the third data file. Let's suppose it goes to 40 GB. So what is the total size of the VM now? Ideally, it should have taken only 100 GB on the data store, but now its size has been grown to 200 GB on the data store. So that's why if you are not managing your snapshots properly, it can become a problem, because now if you are taking snapshots of each and every VM, your data store can fill quite easily, and it can power off your VMs if no space left on the data store. So you need to make sure that you are taking snapshot and deleting snapshot within time, or you're taking it only for the activity. So that's why I said snapshots are not your backup, because in backup you generally take all of your files, copy them onto a separate place. But here, as you can see, all of these delta files are being saved with the VM itself, and your original files are getting logged.
Yeah, so one more thing, like the original file, so let's say it's 100 GB, the original file, and after taking the first snapshot at 1 p.m., 1 to
Yeah,
2 p.m., if we add 10 GB of data,
right.
at that time, if we we cannot access the previous 100 GB data.
No, no. The 100 GB of it's not new data basically. This flat file. So let's suppose this is a C drive, right? Okay. In Windows, there is a C drive in which all the Windows files, program files are saved. Okay. The total size of the C drive is 100 GB. Okay. Out of which 50 GB is free. Okay. But the 50 GB is what? It's your flat file. So because the total size of the flat file is 100 GB, as soon as you take a snapshot, this whole 100 GB will be logged. Okay. Now, what your operating system will see that, okay, I have still 50 GB of free space. You will also see that. Then you say, okay, I can copy more data. Then you start dumping some files or dumping some binaries or dumping some setup into your C drive. Let's suppose you copy 10 GB of data, but for snapshot, what is it? It's a completely new data for the snapshot. So it will save all of this data on a separate file, which is a delta file. Then you take a new snapshot and you locked the 10 GB data. Now they will be referencing each other, but they are stuck in the read-only mode. Now what you did
No, no.
is,
So here is the question actually. So
Mhm,
let's say the first 100 GB which is logged, and
mhm,
while taking the another snapshot,
mhm.
it will take the existing 100 GB plus the new 10 GB, or only
Right.
the new 10 GB.
No, no, only the new 10 GB, but 100 GB is also there in the same data store, right? So the
Okay.
total size of the VM will become 110 GB. Then you created a new delta file. Let's suppose you reinstall the Office. Okay, what you did, you uninstall the Office 2010 and you installed Office 2013. Now, for you, you are performing the changes in the same 100 GB of C drive, right? But for snapshot, that changes are the completely new changes. So what it will do, it will save all of those changes into a new file. So that's how the size of the snapshot grows. So this here. So it will keep on growing basically.
So all these snaps have chain, right? The third one is showing less size, but logically it will be increasing, right? It will keep increasing. Then all the later snapshot will be higher in size.
No,
Is that right?
no. The size of the snapshot will depend upon the number of changes that you have performed. If you see, I have 10 GB, I performed only 10 GB of changes. In the second, I performed 50 GB of changes. It could have been I do not perform 50 GB, I performed only 5 GB of changes. It could have been
Okay.
that as well. So that doesn't matter. The size of the snapshot will matter on the number of changes that you have performed. If you have performed a large number of changes, the size of the snapshot will be high. If you have performed less number of changes, the size of the snapshot will be less. So it's as simple as that.
Okay. So, but snapshot always get created, right? Irrespective of size of C drive, whatever we discussing right now.
Right, right. Guest operating system does not matter for the snapshot. The number of drives that you have. So we are discussing only for the one drive. Let's suppose you have 4 hard drive in your VM. So snapshot will get created. So the delta files will get created for all the 4 hard drives.
Mhm.
Okay.
Okay.
So this
And
is how.
anywhere we can see the size of snapshot, like.
Yes, you can.
Okay.
Just let's take a snapshot. Actually, I deleted all the snapshots. So quickly, let's take a snapshot. Okay, forgot to tell you about this option, snapshot the virtual machine memory. Right now, we have saved the state of only our hard drive. Similarly, I can save the state of my RAM as well. So if I select this option, snapshot the virtual machine memory, it will take the copy of my RAM as well. Okay. Generally, it takes a little bit of time. So that's why I'm not taking the memory snapshots, but yes, you can take. So go to manage snapshot. You can see here. So if you go here, you will see. Okay, actually, it's showing the complete usage. It's not showing the size of the snapshot, but you can create a script. What I have done is for one of the environment, I have created a script which will show me a list of all the VMs who created the snapshot and what is the size of the snapshot. It will run on daily basis so that I can monitor my environment.
Okay.
Okay. All right. Okay. And one more option is there. Sometimes what happen when we have taken a snapshot. So let's go to store. Let's go to files. And also never ever delete a snapshot file manually from the data store. It can corrupt your whole VM. Okay, as you can see here, this win10-0000001.vmdk. So this is the delta file, and it will show you the size here. It's 23 point something KB. Okay, now, sometimes what happen? You perform the delete operation from the snapshot manager, but you are still able to see these delta files. So what to do in that particular case? There is something called consolidate. go to snapshot, and there is option called consolidate. What it will do, it will look for the orphan delta files, and it will delete them. So this is how we work with the snapshots. Any doubts related to snapshots? Please raise your hand if you have any doubt.
No, just a question.
Yeah.
Takes also the permissions and the ownership with the snapshot.
Permissions, sorry, I didn't get you.
The permissions, what has been changed within the VM, it may be accessed from multiple users. So does it take the snapshot? Does it keep the permissions on the folders, the ownership?
Are you talking about the permissions inside the guest operating system?
Yes, that's correct.
Okay. So snapshot is basically at the vSphere level, so it will not impact anything inside the guest operating system. So anything that is running inside guest operating system will remain as is. So it will do not make any changes inside guest OS.
Okay.
Okay,
Yes, thank you.
no problem. Any other doubts? Okay, so next topic is our vMotion. So basically we will discuss how to live migrate a virtual machine, and what are the prerequisites and how the vMotion actually works. All right. Before that, just take 10 minutes, go through your lab, play around with snapshots, and then I will continue.
Okay.
So if you have come across any issue or come across any query or doubt, just let me know. I will be away from my system for 2 minutes and I will come back. Okay, any doubts? Okay, so should we continue for the vMotion?
Yes.
Yes, yes.
Okay, all right. Okay, so we already discussed about how to take a snapshot, how to manage the snapshot, and this is just it is again saying how to delete a snapshot. What will happen if you delete the snapshot? Its changes will be committed. But if you have any changes after the marker, all of your changes will get deleted. So you can perform the delete all, and all the snapshots changes will be committed to the base disk, which is our flat. Okay, and consolidate, basically you do not need to perform the consolidation manually. Generally, anytime the consolidation is needed, VM will automatically throw a warning, and you can run the consolidation at that time. So you just need to go to snapshots and click on consolidate, and it will delete all the orphan delta files. By basically, it will commit all the changes which are present in the delta files to the base disk. Okay, so let's look at the vMotion. So vMotion is a live migration. So what do we mean by live migration? So let me first tell you about what is migration. So migration can be of two types. It can be a host migration or it can be a data store migration. Okay. So let's just see. Now, when we see migration, migration is moving the VM from one place to another place. If I'm saying host migration, it means I am moving the VM from one host to another host, or if I am moving a data store migration, means I am moving a VM from one data store to another data store. Why do we want to move VM from one host to another host or one data store to another data store? The reason is really simple. In case of host, it can be like one of my host is highly utilized. The CPU and memory on the host is very much high, whereas on the other host, the CPU and memory is very less utilized. So I want to balance the load so I can move the VMs from one host to another host. Same goes for my data store. I have very high utilization. My data store is running out of space, so that I can move one VM from data store to another, so that I can create some space in the data store. In case of host, another use case can be a maintenance. You want to perform some maintenance on your host, so that you need to make sure that there is no unwanted restart of your VMs, so that you manually migrate all the VMs from the host to another, and you can then perform hardware maintenance or upgrade or any kind of maintenance on the host. Okay, so the use cases for the migration can be load balancing and maintenance. So these are the two most popular use case why we want to migrate VM from one place to another place. Now, if we have host, either I can perform the cold or I can perform the hot. Same goes for data store. It can be a hot migration or it can be a cold migration. When we say hot or cold, what do we mean by that? Cold means the VM is in the powered off position. Okay, and if I say hot, the VM is in powered on position. Okay, so that is the difference between the hot and the cold. So generally, hot host migration is what known as vMotion. Okay, so whenever someone says vMotion, what they are trying to say here is that they are going to move a powered on VM from one host to another host. Similar, hot data store migration is also known as svMotion. Here S stands for storage. So if someone says that they are doing svMotion, what they want to say is that they are moving a powered on VM from one data store to another data store. So these are the different types of migration that we can perform in the vSphere. Also, Then there is something called suspended migration. Suspended means the VM is in the suspended state. It's neither on, it's neither off. It's like hibernation stage, you can say. All right. So any doubt related to what are the different types of migration and what is vMotion and what is SVMotion?
Yes. What about the cold migration? What?
It's just simple. We call it migration. If you are moving VM from one host to another, it's called, if it is in the powered off position, we normally called it cold migration. That's it. There is no special name for this.
Okay.
Yeah.
So this is just name or some software which need to use for this? It's
So
just
the
name.
yeah, it's a name, and if you want to use the migration, you need to have a vCenter server. You cannot do the vMotion, SVMotion, or migration without vCenter server.
So, but this vMotion and S motion, they are already integrated part of
vCenter.
vCenter, right?
Yes,
Okay.
exactly. Yes. So again, like I said, all of these are features for which you will pay a fee to VMware to get the license. Okay. So any other doubt?
So if so these are optional, right? If you don't need migration, we can while buying this vCenter, we can ask, okay, remove this migration license.
Means you cannot specifically ask to remove the migration. So there are three different types of licenses which you can purchase,
Okay.
like standard, enterprise, and platinum. So accordingly, you can check the features which are required, which are not required, and you can select the package that you want.
Got it. Thank you.
Okay. So this is again just talking about the types of migration, so cold, suspended, vMotion, storage vMotion, and then there is 6.5 onwards. There is a new feature that has been introduced, which is called shared nothing vSphere vMotion. I will tell you more about this in a while, why it is there. So let's look at this chart first. All right. So the migration type is called, okay, means the virtual machine will be in the powered off state. What can you change? Means from where to where you can move the VM. You can move it from one host to another, or data store, or both. You can move the VM from one host to another, as well as from one data store to another. Can it be done across the vCenter server instance? Yes. Across the vCenter server instance means, if I go to my lab, so if you have been working in the lab, you might have seen that there are two vCenter servers in the same console, right? So you can move the VMs between those vCenter servers. So moving the VM between two vCenter server instances. Okay. Is there any shared storage requirement? No. And CPU compatibility. When we say CPU compatibility, means whether the same CPU is required or not at the source and the destination host. So that is not required. Different families can be done. Across the vCenter server instance means moving this Windows 10 VM from VCSA01B to VCSA01A. So this migration will be called as across the vCenter server instance. Okay. Now if we talk about suspended, the virtual machine power state is suspended. You can either uh, move the host, data store, or both. Any instance is fine. Across the vCenter server instance will work. Shared storage is not required, but there is a CPU compatibility must be there. When we say CPU compatibility, generally we are talking about that same generation families should be there in the host. Okay. If we talk about vMotion, vSphere vMotion, again, because it's a hot migration, so the virtual machine will be in the powered on state. What we change, vMotion is specifically for a host. Okay, so in the vMotion, we move the VM from one host to another host. We can move it across the instance, but there is a requirement. vMotion always required a shared storage. What do we mean by shared storage is that we were discussing from the previous class. This type of storage that multiple physical servers are connected and accessing a single storage. So this type of shared storage is required for the vMotion. So that is very much required. Okay, we do not have a shared storage, we cannot perform a vMotion. Okay, we will see in a couple of uh, minute why this shared storage is required while we discuss the working of vMotion. Okay, same goes for storage vMotion. The VM is in the powered on state. What do we change? It's a storage vMotion, SVMotion. So obviously we will be changing the data store. This cannot be done across the vCenter server instance. It needs to happen between the vCenter server. Okay, shared storage is not required. That doesn't make any sense. CPU compatibility does not make any sense here. Now in the shared nothing vMotion, what we do is virtual machine in the powered on state. Now we are migrating both host as well as data store. It can be done across the vCenter server. And now you see here, in the vMotion, we had the requirement for the shared storage. If we do not have a shared storage and still I want to perform a vMotion, then I can use shared nothing vSphere vMotion. So that is the reason this new feature had been introduced. Previously it was not possible. Now it is possible from 6.5 onwards. Okay. So why do we use vSphere vMotion or migration? Again, that for the load balancing purpose and the maintenance, you want to perform any maintenance. Okay, so let's look at the migration workflow or the working of the vMotion, and then we will do it via lab. Lab is very much easy. It's not much. It's just a click, but the main thing here is to understand how the vMotion works. Okay, so let's suppose because it's a vSphere vMotion, so obviously I will need two hosts so that I can move the VM from one host to another. So these are host 1 and host 2. My VM 1 is running on host 1. Now, if I talk about the prerequisites, first of all, both the hosts should be connected to a common storage. This is called as shared storage. Okay, and VM1 should have its file saved on this shared storage. So all the files, the VMDK, the VMX, every file should be here on this storage. Okay, now then let's suppose this VM1 is connected to a network, right? It will be connected to a network. So let's suppose it's connected to a prod network. Now this same prod network should be present on the host 2 as well, is the second requirement. The name should not get changed. Prod network, if it is a VLAN 10 network, the same VLAN 10 network should be present on host 2 as well with the same name. Third requirement, there is a special network which is called vMotion network. Okay, you need to make sure a vMotion network is also in place. So host 1 and host 2 should be connected to a common vMotion network, and they should be able to ping each other on this network. Requirement is 1 Gbps or 10 Gbps is recommended. Okay. So these are the requirements from a vMotion perspective, and also they should have compatible CPU. It's not like that host 1 is running with generation 3 and host 2 is running with generation 1. Both have the same CPU. Okay. Now let's see what happened during the vMotion. Now virtual machine 1 will have some CPU and some RAM. Now this CPU and RAM, because VM1 is in the powered on position, so it will be some data saved inside the CPU as well as RAM, and because CPU and RAM are directly saved on the hardware, so the same will be utilized here. Okay. So as soon as you start vMotion, what happen? Host 1 will communicate to host 2 that VM1 wants to migrate from host 1 to host 2. So host 2, what it will do? It will access the storage. It will find the VMX file of VM1 and it will register at itself. So what will happen here? So a new shadow VM. So we call this as shadow VM. A shadow VM will get created with the help of VMX file. Now you see why we required a shared storage, because host 2 will be accessing the files of VM1. If it is not able to access the files of VM1, the vMotion will get failed. Okay, it will create a shadow VM at itself. VM1 will get attached to the production network. It will have some CPU and memory allocated to it. Now right now it's blank. There is no data inside CPU or RAM. So this is where the actual things happen. So now once the shadow VM is up and running, the CPU and memory is allocated, what will happen? It will, this host 1 will create something called memory bitmap. Okay, this memory bitmap is the address by address instructions. Okay, that at 0 address what bit is stored, at 1 address what bit is stored, at 2 address what is stored, at 3 what is stored, at 4 what is stored. So it will send all of this data in a file to through the vMotion network to the second host. Now it will save all of those instructions in its RAM. As soon as it saves here, the same instructions will be sent to VM1. So the memory which is present in VM1 will be present in shadow VM as well. Okay, now so this is the one time. So this is called initial copy. The time till the time you will see 50% or 60% vMotion is happening. So this memory copy process is happening. Once the memory copy is complete, now it will start copying the delta changes. So let's suppose the vMotion starts at 10 AM. Okay, and the memory bitmap completes by 0 to AM. So there is a now of delay of 2 minutes, right? So between the 2 minutes, whatever delta changes are there, it will start copying them. So once all the data changes are completed of the CPU as well as RAM, it will reach to a state where it is ready for the cutover. Okay, so once it is ready for cutover, it will kill the process of VM1 on host 2, and shadow VM will become your primary VM or your main VM. So all the users request, okay, which are coming from production 10 network, okay, previously they were going to VM1. Now all of these instructions will go to VM1 on host 2. At this point your vMotion is complete and it's a zero downtime migration, means not even a single ping loss is observed. So this is how the vMotion works. Any doubt here?
What about the any real traffic or any real data? So
Yeah.
is there any log?
Log in which sense?
Like any ongoing process or something will be
Okay.
continue on the current.
Yes. So let's suppose what they did is how VMware demonstrated the live migration of the VM. So what they did, they started playing a pinball on the VM. Okay, so they make the players play pinball on the VM. Okay, pinball is a game. Okay, so players were playing games on VM1, and in the backend they migrated the VM from one host to another. The players did not observe any kind of lag or any kind of issue. They simply didn't know that the VM got migrated. So if you are working, if any application is running, it will not observe any kind of data loss, ping loss, or any hang issue. It is a real-time process.
Okay, okay.
Okay. And if you want to observe the logs of the vMotion itself, like how the vMotion is working or how the vMotion is happening, certainly you can go for the vm kernel.log file. Okay, so sorry, so there is vm kernel.log. Okay, so you can browse this file for the vMotion logs, like at which step it is happening. But generally, the small VMs happen so fast that you will not even have a chance to look at the logs. But yes, you can look at it at the later point of time.
Okay, thank you.
Something?
Yeah.
So this is moving one VM from one host to another,
Right.
and there is no one understands it. But if the system already runs in a different type, different program, so the company decides to move the whole structure into another vendor. Do they understand this downtime, or the vSphere can accept it and transfer it from another
No.
system?
So vMotion will only works between the same type of system. So basically you will need EA6i at both end. So if you have any other type of system, let's say Hyper-V or Zen server, you cannot use this technology to migrate the VM from there to here.
All right. Thank you.
No problem. Okay. Any other doubts? Just give me a second. I'm receiving a call. Sorry about that. I had an urgent call to receive. Yeah. So where were we? Yeah, we were discussing about vMotion. Yeah. So any doubts? Okay. If no doubts, then we will do the vMotion using our lab. So let's return to our labs.
It locked me off. One moment.
Yeah, sure, no problem. Take your time. Okay, once everybody is inside server, let me know and we will start.
Yeah, starting the lab once again because it expired.
Yeah, no problem. Yeah, it can expire pretty fast. To stop it from expiring, what you can do is there is an option called extend. Okay, just click on the extend button and it will extend your session by 1 hour.
Okay, I mean, thank you.
Okay, so everybody is inside lab, right? If anybody facing any issue, just raise their hand. Okay, no hands are raised, so I'm guessing everybody is good. All right, so let's see how to perform the vMotion. Okay, the process to perform a vMotion is really simple. So before we start the vMotion, what we will do, we will see that there should not be any kind of network drop. Okay, so open up a PowerShell. So the PowerShell icon is this one right beside putty. So click on this one and the PowerShell will get opened. We will type ping space app hyphen 01a space hyphen t and enter. This will start a continuous ping of our virtual machine app hyphen 01a. Okay, so if everybody is done, should we proceed ahead? Okay,
Yes.
thank you. So right click on app 01a, you will see an option called migrate. Click on it. Once you click on migrate, you will see these three options. Change compute resource only means it will migrate the VM from one host to another. Then change storage only means it will migrate the VM from one data store to another. Change both compute and storage means it will migrate both host and storage. So we will select change compute resource only. Next. Okay, we didn't see on which host our VM was. So let's see. Okay, my VM is on host ESX-01A. Just note down on which host it is and we will migrate it to another host. So migrate, change compute resource. Next, mine was on ESX-01A. So I am migrating it to ESX-02A. If it is showing compatibility warning, just check. I think those can be ignored. And plus, and next, it will ask you to select network. So like I said, the network name on the source and destination should be same. So as you can see, it's VM region A01 VDS comp, and the same is over there, VM region A01 VDS. Yeah, Theo, you have raised a hand. Sorry.
Yes, no problem. Can you please go back on step two and to see what we will select?
Okay, sure.
On the migrate. Thank you.
Yeah. Okay. So app 01A. Okay, just click on app 01A and see what your host is. So in your case, what is the host name? Can you let me know?
It's up -01A.
Yeah.
That look. It's the
Right.
same like yours.
It's the same like mine, right? So we will migrate it to second host, which is ESX-02A. Okay.
Okay, good. Thanks.
So we will okay. So we will right click on the VM, click on migrate, change compute resource only. Next. Now I will select second host, which is 02A. Select next. Now, like I said, the network name, source and destination should be same like here. Okay. Next. Now you can schedule the vMotion with high priority. What it will do, it will immediately start the vMotion, or you can schedule a normal vMotion. It will start vMotion after some time when the system is idle. So we always go for the schedule vMotion with high priority so that we can trigger the vMotion immediately. Next, it will ask you for the review. Okay, that's fine. Click on finish. Once we click on finish, yeah, it happened so fast we didn't even get to see anything. As you can see, the app 01A, in my case, it was on ESX-01A. Now it's on ESX-02A. Let's see if there is any ping loss. As you can see, there is only a ping time which got increased from 1 millisecond to 38 millisecond, but there was no ping loss. If I press on Control C, the packet lost is 0%. Okay, so this is how we perform vMotion. Any doubt?
No.
Okay. If you want to perform a cold migration, the process will remain same. Right click on the VM, click on migrate and change compute resource. Next, select the second host, next and finish, and it will change the resource. Like it's on 02A, I will migrate it to 01A. 01A, next, next, finish. Now the VM was on 02A, now it's on ESX-01A. Okay, so because the VM was in powered on state, it is called cold migration, and app 01A was in powered on position, so that's why it is called vMotion or hot migration. Okay, any doubt?
So how we can migrate to other network, like other one?
Other one means didn't get you.
From the this 1B, from 1A 01A to IF 01-01B.
No, okay. So basically, you are asking how to migrate the VM across the vCenter server, right?
Yes, yes.
Okay. For that, you will need a shared storage between them. Okay, because we do not have the shared storage between all the 4 ESX hosts, I cannot do a live migration. What I can
Okay.
do is shared nothing vMotion. So what we will do in that case is I cannot guarantee the ping loss, whether it will work perfectly or not, because the vMotion network needs to be there. So let me show you in a powered off state. So migrate. We will select this option, change both compute resource as well as storage resource.
Okay.
Next. Now, okay, Arvind. Uh, Now we will select, as you can see, now it's giving me both the option.
Okay.
Previously it was giving only the host cluster option, right? So in this case, I can select my 01B or 02B. Okay. It's in the second vCenter server. Click next. Now I need to select the destination storage, new storage. Next. I need to select the folder. Okay, now here you need to select the network as well. So we will select the VM network. Okay, so that's why I said the VM network needs to be on the source as well as destination, otherwise it will not work properly.
Okay.
That's why I'm doing it for the powered off VM, because the vMotion network is not set up between these 4 ESXi hosts, so the vMotion will get fail. And click finish. But the same process that I done for the powered off position, same can be done for the powered on VM as well. It's exactly same. Okay, now as you can see, the core 01A has been moved from vCenter A to vCenter B.
Okay.
Okay, does this clear it out?
Yep.
Okay, all right. So any other doubts? All right. So yeah. So I think yesterday someone asked me a question about the DRS, about the load balancing. Um, I'm not sure if they are present today or not.
Yeah, actually, I asked that one.
Okay, this is Rajesh.
Sandesh.
Sandesh, yeah, Sandesh. So yesterday you asked me about the DRS or the load balancing, right? And I told you that
Yes.
that we will be discussing today. The reason being, I wanted to discuss the vMotion first. Okay, so as you see, the vMotion generally is done for the load balancing or the maintenance purpose. Now, vMotion is a manual process, means we need to manually migrate the VM from one host to another host. So if we see here, in the cluster, I have got two hosts. Okay. Now, if you see, one host is 51% utilized, another is 23% utilized. Still, it's almost okay. Means there is not much utilization. But in the production, it can be something like that. One host is 90% utilized, another host is only 20 or 30% utilized. So it can be a performance impact on the VMs as well. So how to resolve that case, one thing we can do here is manually migrate the VMs from one host to another. That's a completely manual process. Another thing we can automate is called DRS. DRS is also known as distributed resource scheduling. Okay. Now, distributed resource scheduling is there only and only for load balancing. Now, we talk about basically two type of migration, host as well as data store. So DRS can also work for the both host as well as data store. If it is working for the host, it is called DRS. And if it is working for the data stores, it is called SDRS, or we call it storage DRS. Okay. Now, the main criteria here for the DRS to enable is a cluster. You need a cluster so that you can enable the DRS. So you can click on the cluster, go to configure, and there you will see the vSphere DRS. Click on, sorry, there is an option to edit. Click on edit, turn on, and you can keep it as manually or fully. So I will keep it as fully, and I will keep it as aggressive. Okay, that's it. Once the DRS is active, now it will keep on monitoring the host for the resource utilization. As soon as it sees that, okay, I can would say that one host is getting highly utilized, another host is very less utilized, it will move the VMs automatically with the help of vMotion to even out the load. All right.
You did a little bit too fast. Can you please explain it? And why did you change the migration threshold?
So you're asking for these fully automated and the manual process? These
Is
two?
those steps that you just did from the configure edit?
Oh, okay. Sorry. Yeah. Actually,
You did it way too fast.
it's a habit. Sorry about that. It's like a habit to me, so I like just walk through it. Okay, let me walk through it a little bit slow. Okay, so click on the cluster, go to configure, and vSphere DRS. Click on edit. Once we click on edit, we have this check this button here. I will just click on it and it will be turned on. Okay. Now there are two things to control the automation. Okay. If you're keeping it manual, basically there is not much that can be done by the migration threshold. Manual means all the recommendations will be given by DRS, but none of them will be implemented. Means DRS will say, okay, if you move this VM from host 1 to host 2, your load utilization or your CPU or memory utilization on host 1 will get reduced, but it will not move the VM for you. You need to again manually do it. So it's a manual process. DRS can give you a recommendation, but you have to implement it as a administrator. All right. Now, there is a second option called fully automated. What is fully automated is basically DRS will not ask you. DRS will say, okay, if I move this VM from host 1 to host 2, the CPU or memory utilization on host 1 will get reduced. So it will immediately move the VM from one host to another host. Okay. So it will not ask you for anything. So the whole control is with the DRS or with the vCenter server. So you you do not have to do anything in the fully automated mode. Then there is something called partially automated. What partially automated does is DRS will do half the work, half of the work you have to do it. Means if any VM is in the powered off state, okay, and you power it on, DRS will automatically place or automatically power on the VM on the required host. But if the VM is in the powered on state, it will not move the VM. Okay, means so VM is powered off and it is getting powered on, means its state is changing from powered off to power on. At that time, DRS will move the VM. Okay, but if a VM is powered on and its state remains as VM powered on, then DRS will not move the VM. So as an administrator, you have to move such type of VMs from one host to another host. Okay, so this is what is happening in the partially automated. So generally we keep it as fully automated, so DRS can move the VMs. Okay, now this migration threshold is something like there are 5 limits, means 1 2 3 4 5. Okay, 1 is the most conservative, means a very few migration, only and until it is required, then only DRS will move the VM, otherwise it will not move the VM. Migration 2 you can say 90%, migration 3 you can say 70 to 80%, migration 4 is like 50 to 70% criteria, and migration 5 is like any improvement. So these are the threshold at which the migrations will happen. Okay, so that's why we keep it as 4, 3 or 4 generally, so that not too few and not too many migrations will happen. Okay, so this threshold is defined by this slider here. So we keep it as 3 or 4, and that's it. And with the help of vMotion, now your DRS can even out the load. Okay, so these were the topics that were on the agenda. So we have completed all our topics and labs. We still have time. If you have any other doubts, you want to discuss something, you can let me know. I will be very happy to answer those things for you.
Can just give overview of this vCenter, vSphere. What are the main key tasks actually you need to?
Key task. Sorry, not able to get the question.
Like what are the most majority of time? What are the activity? Like what activity we perform here in vSphere client?
Okay. See, everything is done from the vSphere client itself. You will be spending your 80-90% of the time on the vSphere client in the GUI. Okay. Now, what all activities will you be doing? That's specific to your job profile. Uh, like if you are in the L2 role, okay, you might be creating new VMs. You might be migrating the VMs from one host to another host data store. You might be creating new networks, new data stores, or you are increasing the size of the data store. There are a number of activities that you can do. If you are into the implementation team or a project team, so to say, uh, you might be creating the whole infrastructure basically from the vSphere client itself. So basically, what all activities will you be doing? That's something specific to your job profile, I would say. Okay. Any other doubts or any other topic that you want to discuss?
Yeah, so one more thing. So where this vCenter has been deployed?
You are asking in particular to this lab, or are you asking about in general?
In general, like we are having the ESXi host, let's say ESXi servers, and
Yeah.
so where actually this, so this software, this is the software, right? VMware vSphere client.
Right.
So where this has been installed?
Okay. In
Like this
general,
is deployed as a VM itself, or we need to just install like our normal software?
okay, right. So basically, generally what we follow is in the ESXi host, we will create a new VM. Okay, so let's suppose if I talk about the completely new implementation, okay. Because generally we install vCenter server when it's a new implementation. So you will set up your ESXi host first. So the first thing is to prepare a ESXi host. So you are done. You have installed the ESXi host, and then you take the host client. Okay. Then what do we do is we create a VM on the ESXi host. Okay, and we install the vCenter server inside it. So there can be two type of approach to install the vCenter server. One is known as the self-manage, another is the dedicated management. Okay. In self-manage vCenter server, so what do we do is this is your ESXi host. On ESXi host, we will create a new VM, and on VM itself, we will install the vCenter server, and we will connect this ESXi host to this vCenter server. So this approach is known as self-managed vCenter server. Like the vCenter server is managing the ESXi host on which it is running. Okay. So this is one approach. Another approach is the dedicated management cluster. So what is in this cases? In dedicated management cluster, we have one or two ESXi hosts. Okay, in a cluster on which multiple VMs are running. All of these VMs are running different management components. Like they will have vCenter server, they will have NSX, they will have VRA or other VROps. Okay, any of the management components, all of those management components will be running on these VMs. And then there is a separate cluster which is called compute cluster. Okay, and this vCenter server is managing all of these ESXi host. This is my compute. So this approach is known as dedicated management cluster. So most of the time we follow this approach, self-managed vCenter server, or we can follow the dedicated management cluster as well. So any approach is fully supported by VMware.
Okay.
Does this answer your question?
Yes. So basically, we can install that vCenter as a VM itself on the ESXi
Right.
host.
On the ESXi host itself. Yeah.
Okay, and then we register the ESXi host to the vCenter.
Yes.
Okay.
Okay. Any other question that is coming into your mind? It hasn't related to be just related to this these topics. If there is any question you want to ask outside of these topics, you are free to ask. There is no need to hesitate.
So how
And,
many ESXi hosts we can add in the vCenter, like for one vCenter?
Okay, so for one vCenter server, I think I already told the limits. That is 2000.
Okay, means ESXi host.
Yeah, ESXi host. Yeah, somebody was asking a question.
yeah, I just wanted to understand, give some, like, I think we discussed, but is there any link where we can see what all certificate, what are the course syllabus for those?
Sorry, the voice was not clear. I'm not able to understand the question.
Yeah, I was asking, is there any link on the VMware side where we can see what are the certification path and
Okay.
what are the syllabus for those?
Yeah, sure, sure. Let me share those links. So there is this my learn.vmware. This is the mylearn.vmware.com. Okay. In this, you will see the certification. So this will show you the certifications that are there. Like if you want to go for data center virtualization, what is the VCP, what is the VCAP, what is the VCDX, all those certifications are there. Similarly for network cloud. So you have to select the individual certificate and it will take you to the certification. Like if I select this one, it will take me here and it will show you the prerequisites like you hold no VCP or you have a VCP CMA or you have some other VCP NV or you have a means any of the, and then accordingly it will show you what all exams or what all trainings you need to clear. Okay, so I'm where is the chat option? Not able to see the chat. Yeah, say here I found it. Okay, pinging this link on the chat. So this is the link where you can find all the information related to the certification. And one more link is there, that is docs.vmware.com. This is the official website of the VMware. There you will find the complete information about each and every product. The whole documentations are there. It's a really good site, and you can find the guides of everything. Basically, let's suppose I want to go for vSphere, then which version 6.7, 6.5, 6.0. So let's suppose I want to look at how to upgrade my ESXi environment. So it will show you the step-by-step process. Okay. What are the prerequisites? What are the requirements? How to do it? Everything is there in this site. So it's a very good site. if you are supporting a VMware environment or you are getting into the VMware, so it will help you out.
Okay, thank you.
No problem. Okay.
I wonder regarding this, because we speak about the certifications, when we get, for example, one, like you mentioned the VCP, how easy is to find a job that you will do just that, or that will give you the access to something more advanced after that? Or is it something that do we need further certifications or pre-diplomas to proceed with that to get hired and work on this sector?
Sorry, I didn't get you. Are you asking about the VCP certification?
Yes, this is one example that you mentioned on the link, on the first
Yeah.
link before you press the link for the documentation. So
Right.
you mentioned the VCP. So is the VCP just enough to make you work?
Okay.
Or would you need any like CC or any diplomas from a university or something?
No. So there is nothing requirement like that. So let's suppose you haven't got any VCP certification, okay, and you want to do a VCP in cloud management and automation. So it will say you that you should have at least some experience with the vSphere and vRealize tools. 6 months generally it says. Okay, means either it could be a lab experience or it could be a production experience. Then you need to attend one of the required training. Like I was saying that if you are new to VCP, you need to attend one of the mandatory training. So these are the list of the trainings that you need to attend, and these will get tagged to your mylearn ID. Then you need to clear the foundation exam and then the professional exam. So there is no prerequisites for the VCP basically.
Okay. And do you know how long it takes to complete this certification? Like 6 months, 2 months, 1 month?
So that depends upon your learning speed, basically. So that depends upon you. If you attend the training and you are very good with the concepts, you can clear the exam in 2 weeks. But if you think that you need some time, you are preparing, then it can take 3 months as well. But yeah, for a VCP, I think 2 to 4 months is enough to clear a VCP exam. Okay. Yeah. Fortis has asked some question. Features of the VMware environment are unlocked according to the license board. Correct? Yes, that's absolutely correct. Let me give you a feature comparison between the different editions or the different licenses that you have bought. VMware vSphere 6.7 edition comparison. Yeah. Okay. You guys are able to see my screen, right?
Yes.
Okay. So as you can see, there are these 3 editions. The standard, the enterprise plus, and the platinum. All right. Sorry, I incorrectly mentioned enterprise. It's enterprise plus. Okay. Now, if you see, The vSphere integrated containers. So containers is not present in standard, but it's present in Enterprise Plus and vSphere Platinum. Okay. If you see app defense is not present in standard or Enterprise Plus. It's there only in the Platinum. Okay. So these are the major difference between these. Compare download PDF. So this will give you a complete comparison. So vMotion. So as you can see, cross vSwitch, cross cloud, and in Enterprise Plus you will get more options. If you look at the fault tolerance, it is only for 2 vCPU in standard and 8 in Enterprise Plus and Platinum. Okay. Then most of the features are present. Now, if you look at this, the virtual machine encryption. So if you are security aware, you will see. Please paste the link. Yeah, sure, I will paste it. Here you go. So this is the PDF link. It will give you a comparison between all the features. Okay, and you will see there is the Platinum is more towards the security centric, so it will have more security features enabled. If you do not want those security features, then you can go for the Enterprise Plus or Standard and save hefty fees on the licenses. Okay, so now if you see the main difference between the Standard and the Enterprise Plus, there is no DRS or storage DRS present in the Standard. These are only present in Enterprise Plus. Okay, so if you think that you do not need DRS or storage IO control or the network IO control, okay, so you can skip on the Standard edition. Okay, then you will also not get the auto deploy or the distributed switches in the Standard. So you can compare the features, and if you think that you can work without these features or this is not essential for your environment, basically you can just take that addition which is suitable for you, and once you applied the licenses, all the features that are coming with the license will get opened up for you.
So we can upgrade and downgrade the license type anytime, or
Not anytime. Let's suppose you have an environment who is using DRS, so you cannot downgrade it to standard. Okay, because then there can be a risk associated with it if you directly downgrade the licenses. Yes, you can downgrade the license, but it's not a completely straightforward process.
okay, an upgrade can be done anytime.
Upgrade can be done at any time, yes, because upgrade will give you newer features.
Mm-hmm.
All the existing features will remain.
Okay, thank you.
Okay, for this, so yeah, we can upgrade from a free license to a bought one anytime without a reboot, correct? Yes, that's absolutely right. Yes, we can upgrade anytime without any reboot. Okay, no problem. Yes, somebody is asking.
So from free version, we like what are we can do from the free version, just to learn a point.
From the free version, you will not be able to do much of anything. From the free version, you can create a new virtual machine, you can power it up, you can work in the virtual machine, but there will be no HA, there will be no FT, there will be no DRS, there will be no vMotion. Free version also cannot be registered with a vCenter server. If you want a vCenter server, means if you want to register or if you want to connect your ESXi host to a vCenter server, it needs to be licensed.
Okay.
Okay. Right. Any other doubts?
Thing looks good. Thank you.
No problem. So if there are no doubts, I would like to know the feedback of this class so that it will be helpful for me in my next batch. So that I can learn a few one or few things from you guys as well. So how do you like the delivery? If there is any complaint or if there is any area of improvement that I can do, please let me know so that I can work on myself as well.
Sure. Will you provide that with an email?
Yeah, that's right. Please let them know so that they can give me accordingly.
Sure. Thanks a lot from my side. It was very detailed enough. I don't know the program, but I really love that.
Okay, thank you, Theo.
So you achieved my expectations and exceeded it. I
Okay,
really like it. Thanks a lot.
thank you so much. Okay, guys. Oh, right. Sorry, I forgot to mention one thing. So I don't know if you guys have my email ID or not. So this is my email ID. If you have any questions, you can get in touch with me. And I have my website. So this is my Facebook page. So you can connect me over there as well. I'm there on the messenger. So if you have any doubts, just ping me over there and I will surely get back to you. Or you can connect me via email as well. So it was a very nice experience working with you guys. Thank you so much,
Thanks.
Otis, for your feedback. Thank you so much. Yeah.
Thanks, Vinaya. Overall, it's good. Whatever I was looking from the beginning, I got overview, and now we can go further.
Sure. So this was just a brief overview because we didn't had much time. But yeah, this is a starting point. If you want to learn further, then what you can do is there is a VMware learning portal as well. So it will give you a 1 year subscription. So you can register over there as well. There are tons of learning materials. So it will help you throughout your VMware journey. I hope that will be helpful to you guys. The link is the same as the certification one, which I shared with you. You will find the same over there as well. It's called VMware Learning Zone. And VMware Hands-on Labs. So that is absolutely free of cost, available to you guys. So you had to just create your ID, which you have already done, and happy learning. That's all I can say.
Thank you.
Thank you so much, guys, for your time and being with me. And thank you, Arvind. Thank you. So I will be sharing the recording of these sessions with the institute, and they will share it with you guys. So currently it's in the progress. I am converting these recordings, and I will share them hopefully by Monday, so that you can have the recording links as well. So that if you want to review anything, you can go back and check the recordings.
Sure, thanks.
Okay. Okay, thank you, Rajesh. Thank you all. So if there is no further queries, I will be closing this call in next 5 to 10 minutes. I will be there in the listening mode. So if you guys have any queries pop out, just let me know and I will resolve those queries for you. All right, I will be on mute now. Thank you so much.
Right. Have a good day.
Yathiyo, you were saying something?
Yes. Have a good
Yeah.
day. Thanks a lot.
Oh, thank you. Have a good day. You too. Thank you.